Hello, my wonderful pre-cal class. Welcome to our online math adventure. We're going to be talking about graphing the other trigonometric functions. Remember, we've already graphed what? The sine function and the cosine function. Well, the first other function that we're going to do will be the tangent function. And you're saying, well, how does a tangent function look? Well, when the a is greater than 0, is going to be an increasing function as we move from left to right. And it's going to be approaching a positive infinity to the right, approaching this vertical asymptote, but never touching it, never crossing it. To the left, it's going to be decreasing infinitely, approaching this vertical asymptote, but never touching it, never crossing it. And just like we had the A, B, C, D for the sine and cosine, we're also going to have an A, B, C, and a D for the tangent function. So we're going to graph one cycle of y equals tan of x. So you see here our A is 1, our B is 1, our C is 0, and our D is 0. However, when we do a tangent function, we're not going to have an amplitude. And I'll show you how to use the A in the graph of the function. It's going to be, this tangent function is going to be increasing infinitely and decreasing infinitely. I just showed you that a little while ago and how the tangent function looks. One of the first things that we're going to do, we're going to find two consecutive vertical asymptotes using this inequality. This is the inequality that we'll use all the time. Notice here we have an endpoint of a negative pi over 2, and here an endpoint of pi over 2. When we were doing the cosine function, remember we had this inequality that we used? Well, now for the tangent function, we're only using this inequality. And the period, remember the number of how many radians does it take to complete one cycle? The period this time will be pi divided by the absolute value of b. Whereas when we were doing the sine and cosine, the period was 2 pi divided by the absolute value of b. So you're going to have to remember that this time, here's our period, and this is our inequality. So the very first thing we're going to do, we're going to solve our inequality. Now, and this is the inequality that we're using. But our bx minus c, remember, is 1x minus 0, which is what? Just x. So we're just going to have x is in the middle here, so we have negative pi over 2 is less than x, which is less than what? Pi over 2. And see, this is our inequality. This is our step number 1. And this endpoint right here is the first critical number, and it's also a vertical asymptote. This endpoint right here is the fifth critical number, and it's also a vertical asymptote. Now the period, remember, it's going to be what? Pi divided by the absolute value of b. So it's pi divided by 1, which is what? Pi radians. So it's going to take pi radians to complete what? One cycle. Remember, pi radians is the same thing as what? 180 degrees. Now our increment is the same formula as we had for sine and cosine. It's going to be the period divided by 4. So our period is pi, and it's going to be divided by 4. That is our increment that we're going to use to help us find the other three critical numbers. So remember, our first critical number from our inequality was what? Negative pi divided by 2, which is the same thing as negative 2 pi over 4. And I'm changing to fourths because our increment was what? In fourths. To find the second critical number, we take our first critical number and add our increment, and we get negative 1 pi over 4. Take our second critical number, add our increment, and we're getting what? 0. Take our third critical number, add our increment, pi over 4, we're getting what? Pi over 4. Then take our fourth critical number and add our increment, we get 2 pi over 4, which is what? Pi over 2. So our 5 critical numbers will be negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. And notice right here, this fifth critical number is the same critical number that we got when we solved our what? Inequality. That's how we can what? Double check it. Well, let's graph this So the very first thing we're going to do, we're going to draw an XY axis. Here's our Y-axis, our X-axis. Let me label them. Put my little end points here, my arrowheads. So we're going to have our 5 critical numbers. This one's what? Negative pi over 2, negative pi over 4, 0, pi over 4, and then what? Pi over 2. Now remember, the first and the last critical numbers, this will be where we have our consecutive what? Vertical asymptotes? Our consecutive vertical asymptotes. Remember, these vertical asymptotes are not a part of the graph, but we're using it as a part of our graph so that we will not go beyond this, okay? Because if you go beyond this, then the graph is what? Not correct. So this is a guideline for us. So again, this is our what? Vertical asymptote. Our vertical asymptote right there. And remember, the A is 1, so we put the A, a 1 here, and a negative 1 right there. You see the second critical number. Now remember, let me go back to say this. We had y is equal what? To the tan of x. And remember, the A was equal to 1, which means it's greater than 0. So it's going to be an increasing function as we move from what? Left to right. So this is how our tangent curve is looking. So, but you see the second critical number, since we know it's looking like this, the second critical number, we go down to this minimum, not this minimum point, but to the A that's negative 1. And the middle critical number will always be an axis point. The middle critical number, you see, will always be an axis point. And then you see the fourth critical number, we're going to use our A and go up to that A. And that's how we're using the A. Remember I said we don't have an amplitude this time because this tan curve increases what? Infinitely. Then what we're going to do, a little portion is half concave down, then another portion half is concave up. So we're getting closer and closer and closer to the vertical asymptote, but it's never touching it, never crossing it. So this is an example of our graph here. And remember, you can stop and start this video at any time so you can repeat it, what I'm saying. And here is the graph again. I was just doing it again there to show you what we did. And suppose that the A is less than 0. How is the graph going to look? Well, we have to go back and remember our even-odd properties. Tangent is what? An odd function, so tan of negative x is the same thing as negative tan of x. So when we're getting ready to graph this function, we're going to use that even-odd property and rewrite this as y equals negative tan of a positive x. So the A is equal to negative 1, and it's less than 0. So it's going to be this very same thing, the same 5 critical numbers, but this time, you see, at the second critical number, we're going to go to what? To the A that's what? A 1. You see, it's going in the opposite direction. In other words, it's what? It's a flip through the what? X-axis there. It's a flip through the X-axis. And that is our graphing of our tangent curve. And we have some home practice. And they say that since we're doing this online and we do this home practice, you have to show me something every day so you can get your credit for this, because they say if you don't show me anything that particular day, then I have to give you 0. We don't want any zeros. We want all very, very good grades. So we're going to sketch one cycle of each of these functions showing the 5 steps. So the first thing we want to do is solve the three-sided inequality, then find the period, then identify the increment, then list the 5 critical numbers, and then sketch one cycle. So this is what you're doing, and this is your home practice. So have fun. This is our math adventure. See you next time.